So type 1 diabetes is caused by the autoimmune destruction of the insulin-producing cells of the body that are located in the pancreas. So people that have type 1 diabetes are dependent for their life on the injection of insulin, the administration of exogenous insulin. So this can either be done through multiple daily injections of insulin subcutaneously or through the use of insulin pumps. Now, the problem with this form of therapy is that it fails to reinstate the normal control of blood glucose levels, so that over periods of time patients with type 1 diabetes can have elevated blood glucose levels, and these elevated blood glucose levels affect the functioning of eyes, kidneys, peripheral nerves, and this is the major problem. It's not the day-to-day control of the disease. We know of many athletes that have type 1 diabetes and that can function at a very high level, but all people with diabetes, type 1 diabetes, have this real problem of the late complications of the disease. So for that reason, there is a desperate need for novel approaches to treating the disease. So, as I've just mentioned, we need new approaches to treating the disease. And one approach is to isolate to transplant insulin-producing cells into people with type 1 diabetes. Now these the insulin-producing cells are localized in the pancreas. They're present there in aggregates of cells. They look like small islets, and that's why they're small islands. That's why we call them islets. There's about 1 million or so of these islets in a normal individual. So what we do is we can take from cadaveric donor pancreas, we can isolate or we can purify these clusters of insulin-producing cells, these islets. The isolated cells, they actually look about the size of a large strawberry, so it's not a huge volume in terms of tissue mass. And these cells are transplanted into the liver. It's a very simple operation. They're introduced via a catheter into the hepatic portal vein, and these islets reside within the liver, and people that have the recipients are actually, they're no longer dependent on injecting exogenous insulins. But the problem is that there's nowhere near enough cadaveric donor material to meet the demand, and that's where our technology comes in. So what we're trying to do is to generate an alternative supply of islets, and we do this by using a process that's called reprogramming. So what we do is we take the material that's left over from the islet isolation procedure. That's the bulk of the pancreas. This is the material that functions to produce enzymes that are secreted into the gut, involved in the breakdown of food. That represents about 98% of the tissue mass of the pancreas. It's called the exocrine pancreas. So what we do is we take that exocrine material and we use modern technology to reprogram this and to make additional islet-like cells. The anticipation being that this would be able to increase tremendously the number of transplants per year. For example, at the moment in the UK we have about 60 transplants per year, which is really nowhere near enough. We would hope to take that into the hundreds, if not the thousands. Yes, so Islexa is a small company that was set up through the Cell and Gene Therapy Catapult and the University of Aberdeen. And the aim of Islexa is to take the technology that I've described into the clinic. The Cell and Gene Therapy Catapult have put money into the project, and they manage the project, and they provide expertise in a variety of areas: health economics, regulatory aspects, safety aspects, and so on. But overall, the Islexa itself involves a number of partners in addition to the ones I've just mentioned. They also include the University of Edinburgh, where the islet transplantation team are located, Scottish National Blood Transfusion Service, who will be involved in the scale-up of the production of the cells, and Lothian Health Board. So it's a partnership of various stakeholders with an aim of taking this technology into the clinic within a finite period of time.